Hello, ladies and gentlemen, and welcome to our next unit. So we're going to start a new unit, and it's going to start off by talking about graphing linear equations, which is something that we spent a lot of time doing in grade 9. I think it's our fourth or our fifth unit. However, I'm going to be talking, these numbers here are going to be talking about your chapter in your textbook. So this is a chapter number in your textbook. And we're going to be jumping around. So today I'm talking about 3.5. I think tomorrow I talk about 4.4. And then I come back to 3.4. I just don't like the way that the textbooks ordered it, so I'll be changing that up for you. Okay, so key concept. Well, first of all, what are we doing? 3.5, graph linear relations by hand. So we're going to be graphing a linear relation. Well, what is a linear relation should be a question, and what is a graph should be a question. So key concepts. A linear relation can be graphed by plotting a series of points. Now, a series of points, we should remember, are going to be in the form x comma y. Now, a linear equation can be graphed by plotting a series of points. All right, that makes sense. Or by plotting the y-intercept and then applying the slope to locate other points. Oh, so that is basically saying that there are two ways to graph a linear relation. One is by plotting a series of points, and the other one is by plotting the y-intercept and then applying what's called a slope to the other points. Okay, we'll look into that. Linear relations can represent some real-life situations. Oh, all right. If there's a constant rate of change between two variables, so as one variable changes, another variable changes. And if that's constant, so let's say I get paid $8 an hour. So for 1 hour, I get $8. For the next hour, I get another $8. For the next hour, I get another $8. That's a constant rate of change between two variables, time and what I'm being paid. This is called the slope. Well, we remember that from grade 9. So we have a constant change between two variables. That is referred to as slope. Okay. The initial value, the starting value. Initial is another way of saying starting. So your starting value is going to be our y-intercept. Oh, okay. And the y-intercept is going to be, as we should remember, where the line crosses the y-axis. And it happens at a particular point always. It always occurs when the x value equals 0. So the initial value, your starting point, and the y-intercept is where the line is going to cross the y-axis, and it always occurs where x equals 0. Okay, so we've got a couple of things going on here that perhaps we should talk a little bit about. This idea of graphing. First of all, well, there was a guy by the name of Rene Descartes. And Rene Descartes, no S. So Rene Descartes was a good guy, and he was the first person that we have on record to come up with this idea. What he did was he took a number line, and he said, I'm going to start at 0, and I'm going to go positive this way, and I'm going to go negative this way. He chose it. We can't change it. That's what he came up with, okay? And the line is there to represent all of the points in between 0 and 1, and 1 and 2, and 2 and 3. So like 2.5, and 2.6, and 2.99, and 2.999, and 2.999. So this line represents all those numbers being there. And what he did then was he took another line, another number line, and he put it this way. Very specifically, so it made a 90-degree angle, okay? And he decided that this would be positive. 2, 3, 4, 5. And he used a line here to represent everything in between. So 4.1, 4.2, 4.5, 4.9, 4.99, 4.999. So way up in here, really, really close would be 4.9999. Almost 5. So he's using that number line to show a continuum, if you will. And over here we get -1 and -2 and -3. And he was the first guy to come up with this. And so we call this the Cartesian Plane. And it's named after Rene Descartes. His name's in here, Descartes. Okay? There you go. So this Cartesian plane is what we often call the xy plane, because the horizontal axis we tend to call the x-axis, and it is horizontal. Horizontal, this way. Vertical, okay, it goes this way. This is what we call the y-axis, and it is vertical. This way. Horizontal. You can sort of remember horizontal if you think about the horizon. If you look out as far as you can see, you get that horizon, if you will, of the very farthest that you can see, and you can't see past that point. And then you got your vertical, and you can remember that because you got to look up to the sun, right? So the sun is looking up, you got to look up. So that would be vertical. And what this allowed us to do for the very first time in history, recorded history anyway, is to take a point that's not on either line and represent it by numerical value. And we will all get that point if we come out 3 in the x direction. Okay, now he invented which one you do first. You come out 3 in the x direction, and then you go up 2 in the y direction. We all get there. And so what happens is the first value talks about the x value, how far you come out horizontally, okay? And the second value is the y value, and it talks about how far up we come. So if I come over 3 and up 2, I get this point, 3, 2, and everybody does. So it's the first way of being able to talk about points in a plane. So like this point down here. Well, you had to go over 5 to get to it, and you had to go down 3. So I walked over 5 and I walked down 3. So 5, and the concept of walking down, negative. So this point over here, I walked over this way, so that way, left is going to be negative, so -1. And then I went 1, 2, 1, 2 to get down, -2. And we can have points on the axis, so this point here. So how far did I have to move horizontally? Well, I didn't. So if I'm not going to move it all along horizontally, then my x value is going to be 0. But my y value, 1, 2, 3, 4, I had to go up to 4. There you go. So really important to remember with this stuff, though, is, and sometimes we forget, and when we forget, everything falls apart. The x value, the horizontal value, must come first. Must. The y value, the vertical value, must come second. It has to. There's no way around it, otherwise everything gets goofed up. It's kind of like driving. In Canada, we drive on the right-hand side of the road. If we decide to drive on the left-hand side, things are going to get in trouble. However, in England, they reverse that. In mathematics, we don't have that problem. Everybody, everywhere agrees that x will be our first, y will be our second. All right, so let's take a look at what else we've got going on here. A linear relation can be graphed by a series of points. So, for each line, graphing a line using the y-intercept and slope. So that's what I'm supposed to be teaching you. And here's the question. It's going to say, for each line, identify the slope and the y-intercept, then use it to graph the line. Okay, we'll get there. And this is your method. What method is it? This is the slope y-intercept method. Okay, so that's a particular method, and it says step 1, plot the y-intercept. Step 2, from the y-intercept, perform the rise and the run. Plot the next point. Step 3, draw a line through them. And we're going to get there. And many of you have seen that in grade 9, and some of you may have forgotten about it. But I want to remind you of what you're doing here. And to do that, I'm going to start by talking about the easiest way to graph something like this, and that's to use a table of values. So, table of values method first. And the table of values method had us make a table of values, quite frankly. And they taught you to put your x value first, and then calculate your y value. And then some of your teachers asked you to do a separate column for your actual point that you're going to plot. So, for this example, we're going to look at plotting the resulting picture of that relation using different values of x. Now, you got to choose any value of x that made sense. Okay? And so we could choose -2, -1, 0, 1, and 2. And often your teachers chose that. Don't think that they had to choose that. They could have chosen anything they want. So for example, I'm going to break the pattern and choose -6. Okay? So if I choose -6, I'm going to get 2 times -6 minus 4. So that'll be -12, -4. That's going to be -16. And that will give me the point -6, -16. Now when I look at this point, that's my x and that's my y. I can certainly find -6 on the x. But I can't find -16 on my y, not on this scale. This would have to be extended, and looking at my scale, it would have to be extended too far. Even if I doubled this, I don't think I'm going to get -16 here. So even though this is a point on the line, it's not a good point for me to use using this scale. So let's use something else. How about -2? So 2 times -2 minus 4 is going to give me -4. -4 is -8. So this is going to give me -2, -8. Now, this is my x and this is my y. So -2, -6. Okay, so again, -8, not a really good idea. However, it's not as bad as -16 because I could estimate where that is, and I could do better than estimate. I could actually draw it out. But -2 and -8, we would assume would be about here. Okay? -2, -8. So, -1, -2, -4, -6. How about 1? I should do 0, just because it's in the middle. Let's do 1. And that's probably enough. Now, I could choose other points, but I'm not going to because that's not really what I'm trying to teach here. But let's plot these points. So -2, -8, -1, -6, -1, -6, 0, -4, 0, -4, 1, -2, 1, -2. Let's do one more. 2, 2 times 2, 0, 2, 0. And what we would have done in the past is connect those. And that gave us a nice line. We know what that is. We recognize that. That is a line. Now, when an equation gives us a line as its picture, the equation then gets called a linear equation. And it's called a linear equation because when we do a picture of it, a graph of it, we get a line. So that's how that relates. Great. So that's grade 9 in a nutshell using a table of values. We didn't want to do it that way. We wanted to use, that was one way of doing it. It says here, a linear relation can be graphed by plotting a series of points. That's what we did. But it says or, by plotting the y-intercept and then applying the slope. Well, we need to remember from grade 9 when we look at this equation what the y-intercept is and what the slope is? Well, we remember from grade 9 that our equation is given by y equals mx plus b, where m is your slope and b is your y-intercept. So in this case, 2 is here for m, so m equals 2, and we remember from grade 9 that we call that 2 over 1, and that becomes rise, and that becomes run. Now I'm asking you to remember a little bit from grade 9. So the slope here is 2. We can write that as 2 over 1, and slope is always given by rise over run. We have to remember that. So it's 2 over 1. The b value here is -4. So the b value is equal to -4, which means that that's your y-intercept. Now what does a y-intercept mean? A y-intercept is where it crosses the y-axis. So if it's going to cross the y-axis, remember this is your y-axis, then the x value has to be 0. So this is going to be 0, -4. So this question is asking us to graph this using this method. So if we use this method, it says, number 1, plot the y-intercept. Well, the y-intercept was -4, which means it crosses at 0, -4, which is right here. So there's your y-intercept, which is 0, -4. And then you're supposed to, from the y-intercept, perform rise and perform run. So rise over run is 2 over 1. So from this point, I'm going to go over 1 and up 2. Over 1 and up 2. That gives me that right triangle. It gives me another point on the graph. And what that means is that if I plot this point and then draw a straight line through it, I get the same line. Isn't that interesting? So this is method 1, this is method 2, and obviously method 2 is a lot easier. But we got to know a little bit more for this one. Okay, so we got to be careful. Now, this is graphing a line using the y-intercept and the slope. So you're going to identify the slope. So the slope is always given by, remember, y equals mx plus b. Your slope is your m value. And slope is always rise over run. And your y-intercept is your b value. And your y-intercept is where it crosses the y-axis, which means it's always going to be 0, b for the point. It has to be 0 because it's crossing the y-axis, so the x value must be 0. If it was anything else, it wouldn't be on the y-axis. We have to remember that your y-axis is here, that this is always going to be your vertical. We have to remember that your x-axis is the horizontal. It's down here. And if we can remember all that, then we can graph linear relations. So, we're going to stop here, and then I'll do the other examples with you.